So we're given a special fully discrete 3-year term insurance with level premiums. We're given the death benefits and interest rate of 6%. We want to calculate the net premium reserve at the end of the first policy year. So notice they haven't told us what the level premiums are. So we can't find the net premium reserve. So first, let's find the level premiums. So let's start with the expected present value of death benefits. Okay, so we'll get 100,000 if the person will die in the first year, which is 0.03, and then you want to discount it back 1 year, so that'd be 1 over 1.06 plus. Now, if the person dies in the second year, they'll get 200,000, but that means they have survived the first year, which is 1 minus 0.03, and then they would die in the second year, which is 0.05, discounted back 2 years. If the person dies in year 3, they would get 300,000. And if they make it to year 3, or rather if they survive 2 years and are currently in year 3, that means that the probability is 0.97, 0.95, and then dying in the third year will be 0.93. Then we have to discount it back 3 years. And so this would equal the expected present value of future premium. So because the premium is level, that means it's all the same, I can factor out the premium, P. So the premium gets paid in the beginning of the year. So the first one is at time 0, and we don't have to discount it. So it's 1. And then the next premium will be in the following year. So that means we should have survived the first year, which is 0.97. And then we have to discount it back 1 year. And the second premium means that we should survive 2 years. And then discounting it back 2 years. Okay. So when we do this and solve for P, we get that P is 10,131.17. Okay, the next thing is we want to find the net premium reserve at the end of the first policy year. So this step, there's more than one way to solve this. So a good way to do it is using the recursive formula, but we could also do it a different way. So the recursive formula is probably the fastest way, and I'll show you the other way as well. Okay, so the recursive formula is the time 0 reserve plus the premium, and then we need to multiply the interest rate. And you have the benefit times the probability of dying plus probability of surviving, and then the reserve at time 1. So because we're given a net premium reserve, the initial reserves, the time 0 reserve is 0. So that's true for all the net premium reserves. And so that's just going to be 0 plus the premium, which we found to be 10,131.17, multiplied by the interest rate of 6%. The benefit, when K is 0, so the initial benefit we said here is 100,000. So that's the benefit we'll use. And the probability of dying, so we just go up, that is 0.03, as you can see. And so the probability of surviving will be 0.97. And the unknown is just a net premium reserve at time 1. So if we simplify, we end up getting 7,978.39. Now let's look at the other approach. So this, we would take the expected present value of death benefits. So the other approach, you ignore the first year. Okay, so this is gone. So you basically treat time 1 as your time 0, right? So you have 200,000 as your death benefit, and you have to discount it back 1 year. So you have to discount it by survival. So that means you would probably of getting the benefit, aka dying, is 0.05. Discounting it back 1 year. Plus, now the other benefit is 300,000, and the probability of getting that is surviving year 1 and then dying year 2, and then discounting it back 2 years. And we're given the premium is 10,131.17, and I'm sorry, here we have to subtract. Right, so we're taking expected present value of the future benefits minus expected present value of future premiums. And so here we do 1 plus probability of surviving year 1, which is 0.95, discounting it back 1 year. Okay, so you would solve this and get the same answer. There might be a rounding difference, but it should be pretty much the same thing. But clearly, that's a lot more work than just using the recursive formula.